Math is here not to make your life complicated, but to make it simpler. Let us start this day by having a positive thought, a clear mindset, and a smile on our lips. Good morning, my dear grade 10 learners. I warmly welcome you to another Valenzuela live session on Mathematics 10. This time, quarter 1, week 2. I am Sir Neil Raymond Factor from Mapulang Lupa National High School, your teacher facilitator for today. Before we start, make sure you have with you your modules, notebook, and a ballpen, for we will be solving a lot in this lesson. Be active and use our comment box as your way of sharing your answers. Lastly, let's have fun while learning mathematics. At the end of this live session, the learner, that's you, should be able to acquire these learning competencies. Number 1 is to determine arithmetic means, and number 2 is to determine the sum of the given arithmetic sequence. Previously, in the last live session, you have generated patterns and used the formula a sub n is equal to a sub 1 plus quantity n minus 1 times d to solve the nth term of an arithmetic sequence. At this very moment, ladies and gentlemen, we will have an extension of that knowledge as we talk about arithmetic means and arithmetic series. So without further ado, let's start. We are now living in the new normal setup, a situation wherein we need smartphone or laptop for us to be able to attend online classes. In line with this, allow me to share the story of John. I tagged him as a boy with a dream. As we go along the story, please listen carefully and write down information that you may need to answer the questions later. Are you ready? Here it goes. John is an incoming grade 10 student. Despite being a member of a poor family, he performs well in his undertakings. He finds a way on how to support his studies by having a part-time job to be able to save some money. He noticed that there was a fixed difference in his monthly savings and recalled that last August 2020, he saved 300 pesos. On November 2020, he saved 585 pesos. Lastly, he saved 965 pesos on March 2021. Does he have enough savings to buy a smartphone worth 4,999 pesos that he can use for the upcoming school year? So again, we have here the list. This list shows the amount that John was able to save for some months. For the other months, we do not know the amount yet. We are only given the condition that there is a fixed difference. Does John have enough money to be able to buy the smartphone worth 4,999 pesos? It's reaction time, my dear students. If you think that he can buy the smartphone, press the heart reaction. Otherwise, press the like reaction if you think that he cannot buy the smartphone with his savings. You have 5 seconds to show those responses. You can key in your reactions now. All right, time is up. We'll go back to your reactions later on as we dig deeper into our topic. For now, let's answer some guide questions based from the story that you have heard. You may write your answers on the comment section below. You will be given 15 seconds to answer each question. All right, first question. What month did he start saving money and how much did he save that month? You may comment your answers now. Let's see if you have taken down notes. We still have 4 seconds. All right, time is up. If your answer is August 2020 and 300 pesos, you are correct. If we relate this to our sequence notation, this would be your A sub 1 since this is your starting month. Let's have the next one. What was his final working month and how much did he save that month? Again, what was his final working month and how much did he save that month? You have 15 seconds. Please comment now. You still have 5 seconds. And the timer ran. If you have written March 2021 and 965 pesos, excellent. That's correct. Relating to the sequence notation, this is your A sub n. Next one. How many months did he save money? You may comment your answers now. Again, how many months did he save money? You still have 5 seconds. All right, 8 months is correct. Relating to the sequence notation, this is your n, or the number of terms. This time, number of months. We now write the sequence of his savings per month. For now, we will put blanks to those months that we don't know his savings just yet. In that case, we'll have 300, that is for August 2020, blank for September 2020, blank for October 2020, 585 for November 2020, another blank for December 2020, another blank for January 2021, and the last blank is for February. Then we have 965 for March 2021. Let's now have the last guide question. How much is the fixed amount of increase in his monthly savings? You can type your answers now. Again, how much is the fixed amount of increase in his monthly savings? Time is up. If you don't know at this point, it is still okay, but only at this point. Because definitely, we do not know the amount that he saved for some months. So we cannot tell the amount of increase. In our sequence notation, this is D, or the common difference. So let's recall, right now, we know the value of A sub 1, A sub n, and n. We should now look for the value of D. Luckily, we can use the arithmetic sequence formula. We just need to look for the value of D. So let us derive. First thing is we need to use addition property of equality to add negative A sub 1 to both sides of the equation. Now, A sub 1 minus A sub 1, that is 0. The resulting equation would be this one. A sub n minus A sub 1 is equal to quantity n minus 1 times D. Now, since we are looking for D, we need to divide both sides by quantity n minus 1. Okay? So take note that n minus 1 over n minus 1 is equal to 1. Therefore, the equation would now be A sub n minus A sub 1 over n minus 1 is equal to D. And voila! We have now derived the formula for D. To get the common difference D, we have A sub n minus a sub 1 over n minus 1, or that is the last term minus the first term all over the number of terms minus 1. Let us now use that formula to find d in our example earlier. So using the formula d is equal to a sub n minus a sub 1 over n minus 1, we substitute our values earlier. A sub 1 is 300, a sub n is 965, and n is 8. So we have 965 minus 300 all over 8 minus 1. And that is 667 over 7. Therefore, D is 95. If that's the case, we can now fill in the blanks that we have in our sequence. That to get the next term or the second term, we need to add the first term and the common difference. So again, the common difference D is 95. So to get the second term, that is 300 plus 95. Therefore, that is 395. To get the third term, that is second term plus common difference. So we have 395 plus 95, that is 490. Then plus 95 again, that is 585. 585 plus 95 is 680. 680 plus 95 is 775. 775 plus 95 is 870. And to check, 870 plus 95 is 965. Okay, so therefore, we have fill in the blanks that we have earlier. Now, the terms 395, 490, 585, 680, 775, and 870, these are what you call your arithmetic means. So what do we mean by arithmetic means? These are actually terms between any two given terms of an arithmetic sequence. Basically, these are terms in the middle or in between terms. Let's explore this concept. So let us find the arithmetic mean between 10 and 40. This simply means that we need to insert one term between 10 and 40 to be able to have an arithmetic sequence. To illustrate, we have 10 blank 40. Using our formula, we have D is equal to A sub n minus A sub 1 all over n minus 1. Our A sub n or last term here is 40. Our A sub 1 or first term is 10. And our n or number of terms is 3. So substituting in the formula, we have D is equal to 40 minus 10 all over 3 minus 1. In this case, we have 30 over 2, and that is 15. So D is equal to 15. Now take note that this is not our final answer. That is just our common difference. Again, let me emphasize, 15 is not our final answer. That is just the common difference. So to get the second term, we need to add the first term and D. So we have 10, the first term, plus 15, which is our common difference. So 10 plus 15 is 25. So the mean that we are looking for is 25. It's your turn now, my dear grade 10 learners. I will give you 30 seconds to try to answer our given example. So we have here, find the arithmetic mean between 24 and 80. Let me repeat that. Find the arithmetic mean between 24 and 80. Your timer starts now. Keep on trying. You can do it. So if you're done, you may comment your answers now. You still have 12 seconds. And Time is up. So let's see if you got the correct answer. To illustrate, we have 24 blank 80. Using our formula, we substitute the values. 80 for a sub n, 24 for a sub 1, and 3 for n. So that is D is equal to 80 minus 24 all over 3 minus 1. That is 56 over 2 or 28. Again, that is still not what we are looking for. So to get the second term, we need to add B to a sub 1. So we have 24 plus 28, and that is equal to 52. Great job. Now, let me tell you a little trick. Actually, for this question, you can answer this in less than 5 seconds. How? Take note that we are looking for the middle term, or to say, the average of the two given numbers. So we can just add the two numbers and divide the sum by 2. That is 24 plus 80. That is 104. Divided by 2, that is 52. Our answer. Easy, right? But take note that this shortcut has its limitations. Let's try the next example. This time, insert two arithmetic means between 20 and 38. To illustrate, we have 20 blank blank 38 since we are to insert 2. So we have 2 blanks. So in this example, we cannot apply the shortcut because this time, 2 means are to be inserted. We are looking for 2 values and not a single quantity. So we use the formula. A sub n here is 38 minus a sub 1, which is 20, divided by 4 minus 1. So why 4? Because we have 4 terms now. So simplifying this, we have 6. Again, let me emphasize that this is not your final answer. To get the second term, we need to add b to the first term. So 20 plus 6, that is equal to 26, our second term. To get the third term, we need to add b to the second term. So that is 26 plus 6, and that is equal to 32. Therefore, the two means that we are looking for are 26 and 32. So it's your turn now. I'll give you another 30 seconds to try to answer the given example. So you need to insert two arithmetic means between 12 and 51. Again, insert two arithmetic means between 12 and 51. Your 30 seconds starts now. You can do it, my dear grade 10 learners. Just try and try. You still have 16 seconds. Time is almost up. Last 5 seconds. So let's see. Your answer is correct. So to illustrate this one, since again we are to insert two arithmetic means, so we have two blanks here. We have 12, blank, blank, and 51. So let's use the formula. B is equal to a sub n minus a sub 1 all over n minus 1. We substitute. We have 51 minus 12 all over 4 minus 1. And that would give you 39 over 3 or 13. Again, this is not our final answer. To get the second term, we need to add the first term and the common difference. So 12 plus 13, that is 25, our second term. For our third term, we need to add the second term and the common difference. So 25 plus 13, that is 38. Therefore, the two arithmetic means that we are looking for are 25 and 38. That is now the concept of arithmetic means. Again, these are terms between any two given terms of an arithmetic sequence. Let us now go back to our question earlier. Okay? Can John afford to buy the smartphone worth 4,999 pesos using his total savings? Let me emphasize, his total savings. How are we going to get the total savings? That's right. We need to add his savings per month. So listed on the screen, we have his savings per month. We're going to add that. We have 300 plus 395 plus 490 plus 585 plus 680 plus 775 plus 870 plus 965. The sum is 5,060. He is able to save 5,060 pesos. Remember that the amount that he needs to buy the smartphone is 4,999 pesos. Therefore, John can buy the smartphone and be able to attend online classes. So if you choose the heart reaction earlier, you are correct. Now, let me just use this opportunity to emphasize the value of being thrifty. I know all of us, in one way or another, wants to buy something. If that's the case, we must learn to save money. Prioritize savings over expenses. In the long run, it is more fulfilling to buy things that you worked for. Now, going back to the lesson, the addition expression that we have made earlier is now called arithmetic series. It refers to the sum of an arithmetic sequence. To illustrate the difference, let's look at this table. For arithmetic sequence, we have 5, 10, 15, 20, 25, 30, 35. For arithmetic series, we have 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35. Can you see the difference? Same with this one, the bottom. Nice. Arithmetic sequence talks about the pattern, while arithmetic series talks about the sum of the pattern. Now, it may be easy for you to find the sum earlier, but what if we extend this sequence and you are then tasked to find the sum of its first 100 or even 1,000 terms? Will you list all the terms and add them up? Well, you can do it, but I think a normal person won't do that. So let's explore the given numbers and try to find an easier method of finding its sum. Let us try adding the first term and the last term. That is 300 plus 965. If we add them, the answer is 1,265. Let us look at the other pairs. What if we add the second term and the second to the last term? 395 plus 870. Interestingly, we also got a sum of 1,265. Let us further look for the other pairs. This time, the third term and the third to the last term. 490 plus 775. Wow! The answer is still 1,265. How about the last pair? 585 plus 680. The sum is still 1,265. Amazing, right? That is one of the beauties of mathematics. So earlier, if you can recall, we got a sum of 5,060. Now, based from the exploration, we have noticed that the 5,060 actually came from 4 1,265s. Let us try to see what that 4 is and what that 1,265 is. So let's start with 4. 4 is actually your number of pairs. To be able to get that, we can divide the number of terms by 2. In this case, that is 8 over 2. While the 1,265 is the sum of one pair in the given sequence. For example, 300 plus 965, the first and the last terms respectively. From here, we can now use our variables to be able to get a general formula. Take note again, in our example, 8 is n, 300 is a sub 1, and 965 is a sub n. Therefore, S sub n, or the sum, is given by the formula n over 2 times the quantity a sub 1 plus a sub n. This is called the arithmetic series formula. We use this to find the sum of the terms in a given arithmetic sequence. Let's try to use the formula. So this time, find the sum of the first 8 terms of the arithmetic series 3 plus 5 plus 7 plus 9 plus so on and so forth. So of course, we can just write the 8 terms and find the sum. But this time, let's use the formula. So we have the formula given by S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. So our a sub 1 here, or the first term, is 3. Our n is 8, since we are going to find the sum of the first 8 terms. And for our a sub n, or that is a sub 8, it is still not given as of the moment. But take note that we can compute that. How? We can use our formula for arithmetic sequence and find or compute for a sub 8. So again, that is a sub n is equal to a sub 1 plus quantity n minus 1 times d. To get a sub 8, we substitute the values. So we have 3 plus quantity 8 minus 1 times 2. And if we're going to solve that, that would be equal to 17. So therefore, we have the value for a sub n, which is 17. We can now compute for our s sub 8. So our s sub 8 is given by the formula again, n over 2 times quantity a sub 1 plus a sub n. So that is 8 over 2 times the quantity 3 plus 17. And if we're going to solve that, that would give us s sub 8 is equal to 80. Okay? So I hope that you have followed our solution. Okay? Let's have another one. This time, find the sum of the first 80 multiples of 2. So again, we use this formula. S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. Our a sub 1 here is 2. That is the first multiple of 2. Our n is 80. Since we are looking for the sum of the first 80 terms or first 80 multiples of 2. Well, for our a sub n, again, we don't know yet. We don't know the 80th multiple of 2. So in that case, we can use again the arithmetic sequence formula and find the 80th term, or a sub 80. That is equal to 2 plus quantity 80 minus 1 times 2. And if we're going to solve this one, we have a sub 80 is 160. Now, since we have the value for our a sub n, which is 160, we can now solve for the sum of the first 80 multiples of 2. That is s sub 80 is equal to 80 over 2 times the quantity 2 plus 160. Again, if we're going to solve that, we will get s sub 80 is equal to 6,480. Okay? So it's your turn now, my dear students. I will be giving you 35 seconds to try and answer our next given. We have Find the sum of the first 50 terms of the sequence 13, 20, 27, 34, and so on and so forth. Again, find the sum of the first 50 terms of the sequence 13, 20, 27, 34, and so on and so forth. Your 35 seconds starts now. You can do it, my dear grade 10 learners. You still have 25 seconds. Find the sum of the first 50 terms of the sequence 13, 20, 27, 34, and so on and so forth. Last 8 seconds. All right, your time is up. I hope that you have commented your answers. So let's try. Again, we use the formula S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. Our a sub 1 in this given or the first term is 13. For our n, we have 50 since we have 50 terms. Again, for our a sub n, we don't know for now. So we need to solve for our a sub n using this formula. And that is a sub 50 is equal to 13 plus quantity 50 minus 1 times 7. If we are to solve that, we have a sub 50 is equal to 356. So we now have our 50th term, which is 356. We can now solve for the sum of the first 50 terms. So S sub 50 is equal to 50 over 2 times the quantity 13 plus 356. Therefore, if we solve that, S sub 50 is equal to 9,225. So if you have answered 9,225, you are correct. Good job. And that is the concept of arithmetic series. Let us now summarize what we have discussed for today. So here are some things to remember. First, the term or terms between two given terms in an arithmetic sequence are called arithmetic means. Second, to insert arithmetic means, find the common difference using the formula d is equal to a sub n minus a sub 1 all over n minus 1 and add the common difference to the preceding term to get the next term. Next one. An arithmetic series refers to the sum of the terms of an arithmetic sequence. And lastly, the nth partial sum of an arithmetic sequence may be obtained using the formula S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. Let us now talk about some frequently asked questions about our topic on arithmetic means and arithmetic series. First frequently asked question. What is the difference between a sequence and a series? Alright, I just want to emphasize this point. A sequence talks about a certain pattern. Now, when the terms of that pattern is added, we now form a series. In short, sequence is the pattern, series is the sum of the pattern. Second frequently asked question. How can I insert more than two arithmetic means? So for this, we still apply the formula. The same concept goes as with our examples earlier. We first need to get d by using the formula a sub n minus a sub 1 all over n minus 1. Basically, if you are going to insert more than two arithmetic means, you will have more terms. So n would increase. Next frequently asked question. How can I apply the concept of arithmetic series in my life? Actually, this concept has a huge application. Considering that arithmetic series talks about the sum of an arithmetic sequence, so that is if you are tasked to find the sum of a large data set involving a fixed difference, you won't need to add them manually. You can just use the formula to find its sum. Basically, it would ease you the burden of counting manually. So last frequently asked question for today. Are there any other types of sequences? The answer is yes. There are other sequences aside from arithmetic. And do not worry because the next Valenzuela live sessions would focus on the next type. So be sure to be present next week. So I believe that's it. For your weekly home learning task, answer the what's more part of your week number 2 module, the one that is flashed on the screen. Thank you very much, my dear grade 10 students. This has been another Valenzuela live session of Mathematics 10. Keep safe and have a nice day.